Okay, we're here with Jordan to talk about systems of linear inequalities. Ready to go?
Yep.
Okay, so first let's review systems of linear equations, okay? Then we'll get to inequalities because there's some things in equations that are really going to help us to understand inequalities. So I'll just do some quick reminders here. So here we have the coordinate plane and we have two lines here. When you have more than one line, we call it a system, okay? And what we're looking for is solutions to the system, which means that the solution or solutions, if they exist, have to satisfy both equations. Does that make sense?
Yep.
Okay, good. So we're going to go ahead and graph each one of these. This is both of these are y in y equals mx plus b form, so they should be pretty easy to graph. This first one has the y-intercept at 6, so we'll go ahead and graph 0, 6. Does that make sense to you?
Mm-hmm.
Okay, good. And the slope is what here?
-3.
-3, so we'll go ahead and put in a line with a slope of -3. Now let's go over here. What is going to be the y-intercept here?
+2.
+2, so 0, 2 will be the point. And then the slope here, we don't have anything in front of the x. That means there's a 1 in front of the x, so the slope is going to be 1, and we'll graph it like that. And you can see that the only solution to both of those lines is where they cross. It's that point right there. And if we were to solve this using algebra or just by graphing, you can see that the solution is right there where they cross at 1, 3. Does that make sense?
Yep.
So how many solutions are there to this system?
One solution.
One solution, right? And that solution is the point 1, 3. Now, systems of linear equations don't always have a solution. Let's take a look at an example here. So here we have y equals 2x plus 6. So we'll go ahead and graph that one with it has a y-intercept of 6 and a slope of 2, so it'll look like that. Does that look right to you?
Yep.
Okay, and now this other one also has a slope of 2, so it's going to be parallel to this line, but it's going to cross at where?
-1.
-1, okay? So we'll graph the point 0, -1, and then we'll draw a line with the same slope. Now look at those two lines. Are they ever going to cross if they go to infinity and beyond, both of them?
No.
They won't ever cross, right? So these have one solution because they cross at one point. These will never cross, so there's no solution here. And that's an example of just when you can tell right away if they have the same slope and different y-intercepts, you know they're never going to cross, right?
Right.
Okay. Now let's look at one other case. This is the equation y equals -x plus 4. Let's go ahead and graph that. We'll put in the y-intercept and we'll put that -1 slope. Now this equation over here looks like it's different, but if you look closely, if you multiply everything in this equation by 2, do you see how you get this equation?
Yeah.
So this equation is really just this equation in disguise. And it's the exact same line. So this equation is this line. This equation is this line. They cross each other at every single point here. So how many solutions are there?
Infinite solutions.
Yeah, there's infinite solutions. That's right. Okay, so that's a review of linear systems of linear equations. Now let's really quickly do linear inequalities. So let's set up our coordinate plane. We have two inequalities here. You can see that I made them very similar to the ones over here so that we can quickly do this. So the first thing you do is you graph the lines. Well, they're the same lines as over there, so we'll graph that one. Why did I put a dashed line here?
Because it's y is greater than and not y is greater than or equal to.
Very good, okay. And then with this one, am I going to have a dashed or a solid line?
A solid line.
Good, okay, so let's go ahead and actually, before we graph this one down here, let's go ahead and test our point of 0, 0 like we always do. So we're going to test this point to see if we should shade this way. If it makes this inequality true, we'll shade this way. If 0, 0 is not true, we'll shade the other way, okay? So that we put in 0, 0 here for our x and y, and then you can see that that's going to end up being 0 plus 6, and 0 is greater than 6. Is that true?
No.
No, it's not true. So that means if that is false, then this point 0, 0 doesn't work for this one, so we have to shade the other side. So we're going to go ahead and shade that. Make sense so far?
Yeah.
Okay, now let's go ahead and graph this one as if it were a line. We'll put in the y-intercept, and we'll go ahead and draw the line. You can see it's the same lines as over here, so we don't have to do all the work. And then we're going to go ahead and test that point 0, 0 to see if we should shade this way or this way. So let's go ahead and put in the zeros. And then what's 0 plus 2?
0.
Okay, so now we have 0 is less than or equal to 2. Is that true?
Yeah.
Okay, good. So we're going to go ahead and shade that direction that includes the point 0, 0 there. And because that's true. And so then you can see, okay, there's one color here for this line. There's another color here for this line. And where both colors overlap, this is the solution to the system. Okay? All of these points that are in this double shaded area. Does that make sense to you?
Yeah.
Okay. And how many solutions are in there? How many points are in this area?
Infinite solutions.
That's right. There, you couldn't even count them up. There's so many. So there's infinite solutions to this system of linear inequalities. I'm sorry. Now, it's not always true that you have infinite solutions. Let's go ahead and look at a different example here. I'm going to graph some inequalities that look very similar to the equations that we graphed over here. And I'm going to go ahead and set these up here. You can see that the equations and the inequalities are very similar. Let's go ahead and graph this one really quickly. So it's going to also have that y-intercept of 6, and it's going to have a slope of 2. And it's got the dashed line because it's just greater than. And this other one is going to be a lot like this line here. But before we get to that one, let's go ahead and test the point 0, 0. So we'll put 0 in for x and 0 in for y. 2 times 0 is 0, and 0 plus 6 is? 6. So it says 0 is greater than 6. Is that true?
No.
Okay, so that's false. So we're not going to shade the direction that includes 0. We're going to shade the other side, just like that. So does this look right so far?
Yep.
Okay, now let's go ahead and graph this other one. It's going to be that same line that we have with the negative 1 as the y-intercept and a slope of 2. And now we're going to test 0, 0. And so 2 times 0 is?
0.
Okay, 0 minus 1 is?
Negative 1.
So this says 0 is less than or equal to negative 1. Is that true?
Nope.
So that's false also. So the point 0, 0 is on this side of this line, so we have to shade the other side because 0, 0 doesn't work. So when we shade that, we can see that there's the solutions to this inequality. Up here are the solutions to this inequality, but we don't have any crossover areas like we did up here, right?
Right.
So how many solutions are there to this system of linear inequalities?
There are no solutions.
There's no solution, right? It's just simply that there's no crossover. So that's how you, these are the steps you use and how you find if there's infinite solutions or no solution. Make sense?
Yep.
Great job.